Here's the image that I usually use. I got this image from Dean Wampler, and then I kind of upgraded it for this wonderful summit. And this is the big data architecture, if you will. And we have Kafka right over here in the center. Kafka is going to be a pub sub. It is a very, very popular pub sub. You have other choices as well, like Kinesis and the DataStax one, which I can't remember right now, but there's that one. But Kafka has been a really, really popular one, and the idea for this is, if you are, if you have a website that is accepting applications, let's say a credit card application, comes in here into Kafka as a message, and it stays here for a week by default, but you can change however that looks. It's a buffer. It's a business buffer, that you use, where you hold most of the data that is temporal, and you're able to react to it in real time. What I'm going to talk about in this session now, I know not a lot of you were in my PubSub, so I'm gonna do an intro again, and some of you may be bored if you were on that first one, but I'm going to, my goal is to switch over to the streaming as fast as possible, but I still have to give everybody here an introduction into Kafka, so I'm gonna be doing that. Here's the Kafka Streams right over here. There are different kinds of streaming. The Confluent platform, so Kafka has a backing company associated with it, right? Like HashiCorp has Terraform, Spring has whatever the company name is. It's gone through many different hands, but there's a backing company associated with it. Confluent is the backing company behind Kafka. Kafka Streams is one of the streamings that you can have with Kafka, but they've taken Flink as well, and so Flink is another offering for that. Pinot, if you've gone to one of Tim Berglund's talks, he talks about Pinot. Pinot is the aggregation, business aggregation and analysis. Spark, I think many of us know what Spark is, but I'm going to focus on the one that's on the upper right-hand side, which is streaming. But I'd be remiss if I missed this part right over here, which I think is a very good connection and one of my favorite things, and that's Kafka Connect. Kafka will hold information for about a week by default. You could change that to 2 months, 3 months, infinity, whatever it is that you like, 5 weeks or whatever it is you'd like. But this right over here, if you want to put this into more permanent storage, like your S3, your Snowflake, your RabbitMQ, you can do that as well. But again, I'm going to focus on this part over here, which is, again, let's say someone does a credit card application, comes in through this microservice. We will send the message over to Kafka, and then a stream would then take that message, do something with it, and then post it back into another topic. And that's it. Okay? So good night, everyone. But no, we'll go into more of the details here. So Kafka overview, once again, is if you were in my other session, but again, I just want to make sure that everyone gets this. I could have microservices that have end-to-end or point-to-point communication with one another, but that's going to get fairly complicated very quickly for each of those points. So that's where Kafka comes in as a messaging system, so that microservices, which are in its own bounded context, can communicate with one another. That's the idea behind it. It is very high throughput. And it is used for microservices, again, to communicate with one another. So I could have sales, I could have registration, marketing, analytics, whatever it is I need, they talk to Kafka, okay? Web, Hadoop, or any kind of data source. So high throughput, millions of messages per second, high volume, and stream processing, which is the thing that we're going to be talking about. But I need to talk about the internals, again, on how Kafka works. Things are partitioned. So if I have, what's the analogy for home runs in cricket? Is it called a home run? 6. Okay, so if I wanted to manage all the Cricket 6s, and of course there are, I'm just making stuff, I don't know anything about Cricket. You're going to have to help me out with this, but you have Cricket teams or perhaps Cricket players, and you want, let's say the players, Cricket players, and that's what the topic is. Every time a Cricket player does something or like hits a 6, is that how you call it? Hits a 6? Cool, nice. So if a player hits a 6, then I'll have players right over here and a partition. So in cricket, you have leagues and you have teams within those leagues or divisions. Is that how it goes? Okay. What is it? Perfect? Nice. Boom, I'm there. All right. So, whether whether you want to divide things in leagues or divisions or whatever it is that you'd like, you can do so. Okay. And so that's where a partition would come in, and you would define that by the key. And so that's the way that would work. Inside of every partition, you have offsets. Things are stored 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And every message is immutable. That's key. Okay? That's what makes it fast. We don't care about, going to search at offset number 2 and, mutating that message in any way. It is fixed. It is set. The only thing that changes is that these messages will disappear by default in 1 week. So producer produces, and we hit that offset. Data is temporary. So again, things are going to be expunged, and it may look like this, 201. Every message has that address or has that offset, okay? And if we add a new message, then we add to that particular offset. How our message is consumed, it is a pub sub. It will soon be a queue as well, but it's generally called a pub sub. But the messages stay there because it is a pub sub, okay? Other consumers will want to consume from this, right? Other microservices are going to want to consume from this. And what we will do is for whatever consumer name that is, it will mark that offset. So when new messages are going to come in, it will read from that particular offset. And then we'll read from 3 and 4. Okay, I could read from the beginning. I could read from the end. I can also read from a particular point. So if I have my own personal storage, I could say I want to read from 3. Oh, that's a little bit off, but I could read from 3 and get the information that way. The thing to note about Kafka, and here it is that I can have particular partitions. Someone give me a Cricket team name. Simi? What is it? Asivi. Okay. So if the key is Asivi and that team had something spectacular or some sort of event, the key would be Asivi, and that would enter into that particular partition. The idea for a partition is if I have Asivi as that particular key, then I should always find Asivi in that particular partition. For another team, so again, I'm just managing events that are happening per Cricket team, I would have another partition where that information would go into. Let's do stocks. Let's say topic B are for stocks and stock trades. If I have a key for the stock symbol, I should expect all oracles to be in one partition. I should expect all Target to be in one, all of Nokia to be in one. And that's the idea for that. That way I could do groupings, and that's going to be important a little bit later on when we talk about streaming. Okay? And here's another one. Now, what we're looking at here are leaders or leader partitions. Sorry for the repeat for some of you that were in my other partition, but it's a good review. B2, if I need to write to B2, I'm going to write to this broker. That's the leadership. All reads and writes go to the leader. B2 is the leader here. If I need to read or write to C2, I would write to this broker. If I need to read or write to A2, I would read and write to that broker. Therefore, everything is distributed, everything is scaled. One broker doesn't become hot, is the idea behind all this. If I had replication, this is the way it would look. I would read or write, if I need to read or write to B2 based on distribution, I would do this to, I would do reads and writes to Kafka broker number 0. But the pawns that I have here are the backups. This is a backup to B1. The leader is on some other broker. B1's over here, it's still a pawn, but the leader here is on this one. All reads and writes go to that leader, okay? I could field questions since it's the last session, so I don't mind going over. Everyone okay? Okay. So we have messages. Everything is message-based, okay? Everything are zeros and ones internal to Kafka. But I can have a message that is JSON, as Avro, as just plain text, as numbers, or whatever it is that you would like. But generally, we have a key that's associated with it, because with a key, they go to a particular partition. And this is important. If I want to do a group by a key, so like a stock symbol, I should expect that all Oracle stocks are going to be in one partition, all Fords are going to be in another partition, etc. So the key is essential, because what that key is going to do is ensure that messages with a particular key are all going to be in that same partition. And that's going to be important when it comes to streaming. So just something about how producers work. We have a batch. Batch is a way that I can collect and organize multiple messages in one. The analogy that I use is a train or a bus, right? Every person is the message. We get a higher throughput if everyone goes onto that bus, right? Otherwise, we're sending a message at a time, which may not be too bad, right? So let's take India traffic. Your traffic's, pretty nice, pretty open space, not a lot of congestion. No, wait, no. But, I see buses and I see, what are those tiny little trucks called? What are they? Oh, okay. So you have those kind of trucks, and you have like a difference there on like throughput, right? If you have a bus, you can have more people onto that bus, and you can transport people very quickly on here. And plus, it lessens the congestion of the network, i.e. your roadways, right? So you have the same kind of analogies. But sometimes you want low latency. Low latency is, I got a motorbike at home, I'm going to hop on that thing and go, right? But the thing about a bus is you got to wait for that bus to come over. Same sort of thing here. You would have to wait for that batch to be created, so that way you can send that out and you can add and have more messages on there, but you get a higher throughput for that. So your balance is always a higher throughput or lower latency. Lower latency, boom, get going. That message is going to get there on the broker quicker. But, if I want to do things with a higher throughput, I can do that. Thing is, we know where everything is going. And here it is. And again, I know this is part of a review, and sorry if it's boring for some of you, but this is the way things find its way over to a partition. Yeah, go.
Can messages in one batch go into different partitions?
No. That's this thing. Sorry, I didn't mean to say no like I'm angry. No, it's, I meant to say no in a friendly way, but yeah, the answer is no. A batch will always go to one partition. They will not won't split apart over the network and find its way. They have a direction and they know where they are going. And here's the image for that. Every batch has a place to go. And the analogy for that, and thank you for asking that question, the analogy is like you go to a train station, you get a ticket, right? You know where you're going, right? You look up on the placards or the signs and you know where you're going. Same sort of things happening here.
What happens to keys? The message key, if they're not different, or will it be one key for all?
They could be different. Here, let me show you an example of that, because here's the formula here. And I'm going to go to murmur hash right over here. So if I have ORCL as the key, let's do stocks on this one. So this would be Oracle. And let me bring up Scasti, which is a Scala editor. So here's this number right over here. And so if I bring, I think this is the same one. Yeah. So if I had like 25 partitions, all of Oracle are going to be in the 19th partition. So if I need to do a group by stock symbol, this is great because all of Oracle is going to be in that particular partition. But I have 25 partitions. Out of all the stocks in the world, yeah, you're going to have multiple keys in that one particular partition, right? And so that's the way that's going to work. But go ahead.
A Yes, but how will I know which one is going where?
That formula?
So basically, is it like we have to have our custom formula to always figure out what is my...
You don't need a custom formula because this is the default formula. But if you want a custom formula, absolutely, you could plug that in. It's called a custom partitioner. So you can customize it, and so you could say, I want to go here, I want to go here, I want to go.
For example, if I want Apple stocks to go one partition.
That's true. Yeah. So like, let's say invoices, and you have one customer that's 75% of your business, you probably want to divide that up in some sort of way. Yep. But the idea for this is every batch knows where it's going before it gets sent out. Very much like a train, you know where the train is going to go. We have acknowledgements. I'm not going to delve too much into this, but we do have acknowledgements that we could get an acknowledgement back. If you do have questions, reserve those questions till after the session, because what I want to do is I just want to make sure that we head into streaming. I'm going to skip that demo. I'm going to do one just big demo on producers and consumers, then dive into the streaming portion. Consumers are not just one consumer. We do this as a team of consumers called a group ID. Oops, sorry about that. So a single consumer is going to be inefficient for large amounts of data. Again, the analogy for this is if I ask you, oh, you got a notebook there, great. You got a notebook and a pen, write this down, you ready? Right, if I'm going like that and I'm asking him to write it down, and I'm talking very fast, that's not very fair to him. So you could say, okay, I'll take 30 seconds, but after that 30 seconds, then you take over or whatever. Okay, that's the kind of thing on here. I have multiple partitions, so I could use a consumer to consume these particular messages. I could have a partition that's assigned to a consumer. Therefore, things are scaled well, and we have performance. Now, this is how we deal with streaming. And that's why I have this introduction here. Consumers are one consumer per one thread. But typically consumers are going to be in their own machine or their own virtual machine in order to do it. Kafkas will also track those offsets as they are consuming these messages. That's going to be important for streaming as well. And here it is. Streaming is nothing but a consumer and a producer. In fact, you could write your own with that consumer producer API, because all it is I'm going to consume from a topic, do something with it, and then post it over to somewhere else. But the important part is I need to track these particular offsets, because I don't want, or I want to at least minimize the at least once semantic, right? Which is for every message I produce, at least once means I'll get it at least one time, but I could get it 2, 3, 4, 5, 6, 7 times as a duplicate, just because it's distributed computing and distributed messaging. Consumer offsets are, I want to read that message, that message, that message. I've read 0, 1, and 2. I'm going to mark 3 as the next one, and that's what the offsets are. Rebalancing is when a consumer fails. This is going to be important for a stream because, again, a stream is nothing but a consumer producer. If a stream or if a consumer fails, well, not fine, but it's fine because we're able to handle it, and we should be able to heal for that. And that's what a consumer rebalance is. It's a way to mitigate when consumers go down or when consumers are added. This is an important part over here. And if I come in over here, and if I go to source main Java right over here, and here's a consumer, and let me go ahead and highlight this. If I come in over here to the consumer, maybe, and if I do the following right in here, and if I do like a state, like private hash map, where I will have, I don't know, the stock and the average for that particular stock. And let's say as a consumer in here and dot, 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 I'll do a dot, dot, dot here. I'm going to state here that this is bad, right? It's just memory, right? Every member variable that you write in a Java class is just memory. That's where things are going to get stored. If this consumer goes down, there it goes. There goes your averages or any kind of aggregation that you are trying to do. So that's a bad thing. And that's what this slide is about here. Although unavoidable, this will create an unfortunate pause, and we'll show you that, and it will lose state, okay, when it comes to a consumer rebalance. The idea here is if one of these goes down, then the other consumer is going to take over. This is groups and how groups work. This is also the way streams are going to work. If a stream process or a consumer goes down, the way that's done is through a heartbeat. So that consumer or stream process is going to say, I'm alive, I'm alive, I'm alive, I'm alive, I'm alive. Group coordinator is going to be one of the Kafka brokers. It's going to say, okay, cool. I won't rebalance if something bad happens, okay? And that's going to be a part of streaming as well. A consumer could leave a group by just calling close, and when that happens, a rebalance occurs. So here's demo for consumers. I'm going to do it in one big fell swoop. So that way we just understand how consumers and producers work. First thing what I'm going to do is I'm going to come in over here and I see my orders is the name of the producer. And again, I'm just going to lightly talk about this right over here and just show you an example. And what I'm going to do is localhost 9021, and here we are. And I'm going to go over to topics, and I'm going to create a topic called my-orders. And here it is. And I'm going to create 3 partitions for this, and there it is. So 3 partitions. And what I'm going to do here is, and if you saw this already, you know where I'm headed towards. I'm going to send, and it's just going to be simple. I'll have a key for a US state, Oklahoma, Alaska, blah, blah, blah. And the values are just going to be some sort of random value. So what I'm going to do is I'm going to go ahead and run one. And here we go. I'm going to run the producer, and away we go. Now, as I run this, there it goes. And what we see here, and maybe I could expand on this down here, is that Nevada for $75,617 is in partition 1. Alabama is going to be in partition 1. And here's the thing, I should expect all of Alabama to be in partition 1. Here comes another one. So I have this on a loop, and it's just creating messages for me. Wisconsin's in partition, are they all of them in 1? Well, I'm hoping for a different one here coming up soon. So everything should be in its place. Missouri is 1. Oh boy. I thought I did different ones. Let's try another one. I should expect 0. I'm just unlucky right now, I think. Or at least I hope. One more. Don't make it 1. Under 30 seconds, and what's the next one? Come on, Utah. Oh, darn it, partition 1. Here, let me come in over here. I just need to verify. Yeah, I did 3 partitions. So it should resolve itself. But all of Utah should be in a partition 1. I think New Mexico is going to end up in 2, and some other states are going to end up in 0. And I should expect that because that's how the key is going to be distributed. Now, what I'm going to do over here is I'm going to launch the consumer. Oh, there it is. Okay, excellent. Illinois is going to be in partition. Nervous about that one. All right, so I'm going to create another terminal now. And what I'm going to do is I'm going to launch a consumer. Okay. And if you're interested in the code or a description of how this works, I will tell you after the class because I kind of want to go to a stream. But I also want to show you just the way this works. So I just launched a consumer, and this is one consumer. And if we take a look over here, what we see is that this first initial consumer is taking on 0, 1, and 2. It took on all the partitions, which is fine. But when load becomes heavier and heavier, what I'd like to do is I'd like to run another consumer. And here's number 2. Now, we'll see over here, this just got my orders number 2. So this one's listening to this partition number 2. This one got rebalanced somewhere here. Here it is. And this one says revoked, and here's what a rebalance does. You lose them all. Every time there's a rebalance, you lose all the assignments, but you gain them back, or at least you gain a portion back. So what we saw here is this one has 0, 1, and 2 revoked, but what we see then over here is that this has 0 and 1. I'm going to open up another terminal, and I'm going to run a third consumer. But since I have 3 partitions and 3 consumers, I'll have that perfect one-to-one match on that, right? And here's this one. This one has 0, this one has 2, and then this one has 1. Okay? Perfect. Now, I'm going to add one more, but this is weird, right? Because I have 3 partitions, and here's the 4th, and that just means, oh, this one got 1, kind of interesting. This one has 0. This one has nothing, right? So this one's unemployed. But if I say, and that's perfectly fine, because if I take this one down, the one that was unemployed for a bit, I was one of these ones, got the assignment again. And that's what a rebalance does. Consumer has more work to do, right? Because just like in life, it's easier to create data than it is to consume data and do something meaningful with it. And typically what do consumers do? Write to a RESTful service, that takes a while. Write to a database, that takes a while too, okay? So, just want to mention this right over here. If you want to see this in total on how it works, you could take a look at this particular website, softwaremail.com, Kafka visualization, and here's how that looks, okay? Okay, so you can play around with this particular visualization. Let me give you that URL again, and then that way we could go into streams. Now, why did I feel like that reintroduction for some of you who attended the previous session was important? Well, one, some of you didn't go to that session, so an introduction was in order. But that's the way Kafka works. Multiple partitions, they're scaled across multiple brokers. Consumers are their own machines. Producers are on their own machines. And that's the way Kafka works. And so we will jump right into the streaming portion. Okay? Yeah, do it. What's up? The consumer IDs? Oh, they're all the same. Yeah, they're all the same. Excellent question. Let me go back to that code. Well, it depends what you mean by IDs, but I think I know what you're asking. So if I come in over here to the consumer, and here's the consumer over here, the multiple consumers, and it's a great question, it's called the group, it's not called that. It's called the group protocol in Kafka. And here's the command right over here, group ID. They should all have the same group ID. And they could be on different machines, which is the idea here. But they should be all this, because otherwise they'll be the same. They'd be all in the same team. And so the other thing is, I could have another set of consumers that does a different job, and that would have a different group ID. Every consumer of that same group ID should be binary equivalent. They do the same job, otherwise it wouldn't make sense. Okay? And that includes the streaming as well. Okay. So wonderful. I'm going to talk about this topic because this is going to be important for streaming as well, and that's compaction. Okay? Form of retention with the same key. And so let me just jump right into this. And here it is. So on to this one here, I have the following with these keys right over here. I have this message. So the gold keys here are just the keys that I'm representing here, and they could have multiple values. So let's say that you're hired in a company, and you saved the company $1 billion, which is big and huge, and I have an employee record. And let's say on this particular partition and this particular topic, and let's say for this topic, the topic is called employees. Okay? And so as an employee, you just save the money, or you just save the company tons of money, and you get a raise. So your original employee record has all your information, but I'm going to, or the company's going to give you a raise. But the way Kafka works is that every message is immutable, and we have an append-only situation, right? You don't go into a record, you don't go into a message and change it. That's the thing here. So how do we affect a change? Well, we create a new record with all the old information, but the thing that we want to change, we'll change it, right? So there's an old record with your name, with your salary, etc. I'll create a new record with a new salary, but everything else stays the same as a new message, and there it is, right? That's how I affect a change. Now, do I care about the past? And let me slow down on that one. Do I care about the past, right? If I don't care about the past, then I just want to expunge everything else before it. Because as an employee record, I only care about your latest state. This is like your checking account. This is like your savings account, right? Do you care that back in, 2014, your balance was a certain number? Maybe. But typically for these things, you only care about the change log, the state that it's in right now. And that's where compaction happens. So you will configure your topic to either have compaction or not, okay? And that's up to you, because these kind of topics are going to be like a database, and we call it a table, okay? So keep that in mind, a table. Your balance for your checking account or your savings account is a table. Employees is a table. So what I have over here, let me come back again. So I have topic A and topic B, the destination for this. So what I'm going to do, or like what this stream is going to do, maybe it was assigned the partition 0 right up top. This will ingest a message, and once we have that particular message, then what we're going to do is we're going to do a transformation. We want to do something with it in real time. And so what we'll do is I'm going to do the transformation, and you'll notice here that the messages turned from white to orange. I use that to indicate that I'm making some sort of change, right? Maybe I'm adding a tax to it, or doing something with it, and that's a transformation. So I've done my transformation, and now it is a producer. That's the pattern. It is a consumer producer pattern. So once I have this, then this would find its way into different locations. Maybe they'll change the key or do something else with it. And that's what a stream is, okay? I ingest, do something with it, and I produce elsewhere. So let's say this is the message here. And let's say I want to do some filtering on this. So here's New York and 100 here. And this comes from one topic. So this icon that I'm showing here is one topic, New York 100, and I have a filter as part of this. Filters go a long way, and you could do a lot of different jobs with a filter. So this is like a high-end filter. Maybe if a customer spends too much money with us, we kind of want to handle them with care and make sure that everything is good. So here's New York 100. Is it greater than 10,000? No, I'll just go ahead and ignore that one, right? If it is greater than 10,000, let's say I got an order in from Ohio for 20,000, I'll go ahead and put that into the new topic. You could put this with shipping distribution centers, right? If it's in a certain geographical area, then one shipping center is going to handle those particular orders. And then they could just pay attention to that one particular topic. We could also do aggregating, which is the group by and the aggregate. When you do a group by, you create a table. That's just a natural thing with data. And that'll be the case here. If I do a group by key, I'll need a table that is associated with it, right? So let's say these are a chain of events over here, and you're the group by, right? Process, and let's say it's a group by key, and you're the average, right? You want to calculate an average, and we're doing like, let's do like stock symbols, right? So stock was purchased, you're doing some manipulation, and you're the group by, and you're doing a group by oracle. But what do you want to do with that? What is the average sell price? And that's going to be up to you. So someone's going to have a notebook. Someone's going to have a clipboard, and that writes down oracle. And these are all the sales that have occurred, but you're the average person. So you want to take those numbers that he is aggregating by that key and do an average for that. So that way that can go through, right? If you're just manipulating, or if you're just getting the sell price for a particular message, you don't need state, right? You're just extracting the price and changing the way that message looks. So that way it goes over to you. You have a job to do. But the moment you have a group by, you need a clipboard, because otherwise that's going to be pretty hard on you. And then you're the aggregate that's going to take all those numbers and do something with those particular numbers. And that's what's going on here, right? If I group by key, right, someone's going to have to hold on to that information. And then what do we do with that information? Maybe I just want to do a cumulative sum on it. Now, I'm going to change the color of this message again to show that it's a different kind of message. This is the aggregation for it. And I'm going to go ahead and place this over here into that new topic. Here's New York 20. Group by key. What am I going to do with it? Do a sum of it. So far New York has, 20. New different kind of message. I'm going to color that orange, and I'm going to paste this, or I'm going to put this over to the new topic. This new topic is going to show New York 20. New York 60. Group by. Now I have two elements here, 20 and 60. What do I wish to do with this? It's a sum, so I'm going to add 80 to this. You see how this is different now? It's kind of like your checking account. It's like your banking account, right? Your banking account is a stream of deposits and withdrawals. But the table, I gave it away. I was going to ask another question. I already answered it. But on this side over here, that is your aggregation. If you ask, what's my balance in my bank account? Well, it's the aggregate of all your deposits and withdrawals over time. So I gave it away. I was going to ask you what the right one is. Well, here, let me finish this one. So yeah, the new aggregate for that one is going to be 80. But the thing about, so here it is, 20, 60, and we'll go ahead and have 80 as the new aggregate. And so we'll take that 80 and then we'll push that over to a new topic. We have two different identities here. This is a stream, individual events called event sourcing. These are the events that make it up. On the other side, that's going to be the aggregate or a table, right? I should have New York 80, right? New York, I should have West Virginia, I should have Texas, which is the aggregate, and things change over time. Do you have in your cricket stadiums or whatever sports stadiums, do you have something that as you walk into the stadium, it counts you? And at the end of the game, it says, I don't know if you do this in cricket games. Thanks for everyone for coming. We have a record audience of 60,000 people in this stadium. How do they know? How do they count it? They have an indicator. What's that indicator called?
Well, counter.
What is it? A count?
Counter.
Counter? Is that what you call it? Okay. Well, we call ours turnstile. I don't know if it's just like a different thing. So turnstiles are they the metal things that go like that? They're like 3-prong, and you walk right through it, and it goes kerchunk. And of course, if you see the more mechanical ones or the more analog ones, it goes 1, 2, 3, right? That's your counter, right? It's doing a count. What's it really doing as far as data goes? Group by that device and then sum. And who's the stream? You, right? You're the stream of people entering the stadium, right? You can't like put everyone in like one place and do 1, 2, 3, 4, 5, 6, right? That wouldn't work. And that's what exactly this is. So each one of those is the aggregator for this, but we have partitions, right? So Ohio could be over here, but New York would be over here. let me ask you a question. Do I care about the past? The latest count, which is an aggregate, which is a table, is 80. Do I care about the past? Nope. Compact it. There it goes. Okay? So if it's a table, you compact it. Now, for every stream process, there is a storage that is associated with it. There has to be, right? So let's say this row here is managing Target, Ford, and Microsoft, right? And that's what this one is, because they're assigned a partition that has those particular stock symbols on this one. What if they go down and, like, let's say that partition is now assigned to you, but this has gone down? You'll need that aggregate, right, before you start performing the job, because you'll be like, where are we with this sum right now? I need the latest sum. So the way we do that is the following. Every stream process will have a database as part of that stream process, because if it goes down, what it will also do is it'll back it up onto a topic. Okay? So if it says the average target price is this particular stock, so that way when you take over, you can then take over that state and continue going. Okay? And it's typically going to be a RocksDB. And so, given this one, every one of these is typically going to be its own machine in the way that works. And there it is. And so what I'll do is I will consume, and let's say there's a group by associated with it, like I'm doing a group by and an aggregate. This state store is going to be updated, and this is per stream application, and we'll do any kind of manipulation here. Again, extract, transform, load, but in real time, and then we will send that over to wherever we need. Okay?
It gets updated every time you when you say we don't care how fast. So that 20, so then 20 will be updated by 80, or because 20 was already written in there?
Yeah, it's both. I mean, it's written automatically. So
Right, every time. It will, like 20 will be replaced by 80 in that case.
right. Yeah, and any kind of update that you have, it'll just continually be updated. But it's not the regular kind of ETL that takes place at the end of the week or whatever, right? Once that message is there, ingested, do something with it, and if I need to hold on to an aggregation, I'll do so. Yep, as it's going. You could also set things up just as a holder of variables, as some holder of state. You don't necessarily have to have it as a group by, but you could also do that as well.
So is there any, like ETL, when you said transformation is huge, there's a lot of variety. So here also there is some limitation of transformation, or we can do only certain types like aggregation and filter, or we can do all kind of transformation that we are currently doing.
In fact, they get it's added more and more. The API is so extensive now, and I do Kafka training. It's hard to keep up, but yeah, there are so many different formulas and different kinds of aggregations that you could use. We have things like co-groups, of course, group by with a count, group by with a sum. You could do your own averages or whatever kind of things that you want. So it's becoming very limitless of all the different kinds of applications that you could do. And that includes windowing as well. So as time goes on, we have different kinds of windows, and again, hard to keep up. We're now at 6. I'm going to just show you the major 3 on this one. But here's a tumbling window. So if I want to, again, I'm just consuming and producing. Here's the tumbling window here. So let's say I have this window and I have 5 minutes. A tumble is going to be, I have a window and I want to shift by, All right. Oh, here we go. So if I have a shift, and let's say a window of 5, and I want to, move by 5, that's what a tumbling window is. It's a size and how we're shifting. So shift, 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 but notice here, it is by 5 minutes that we are shifting, right? Hopping window is going to be a little bit different here in that I have a size of the window, but the shift is going to be smaller, or typically smaller. You could have whatever kind of shift you would like. So let's say 2 minutes. And so anything that falls or any kind of event that falls within this particular window, I could aggregate it, do a sum, do a count, do an average, do whatever kind of aggregation that you want. It is usually combined with a group by in that particular case. Okay? So wonderful. This one's a session. So session is, I'm going to aggregate, 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 and then what I'm going to do is I'm going to have kind of like a time that I'm going to wait here. And let's say I want to wait for 5 minutes. I don't see anything else, so I'm going to make that a window. Let's do this one. Think of like a stock trade in this, like between 12 p.m. and 2 p.m., lots of buys and sells, and then it was quiet, right? This is where I want to, ingest that and determine what's going on. So, using the same thing. Oh, that's a wonderful question. How is this persisted in the database? As Kafka being the database, I think is what you're leaning towards there. It is a group. Whenever you have a window, you typically have a group as well. And if you have that group, you are storing that into the state store, and that state store is also being backed up in Kafka. And the results of this, you're going to put into another topic. And once that's there in the topic, that's your storage. But if you want to extend that further, every topic, you can use Kafka Connect to take that information and post that into a database. And here's a little bit of what Kafka Connect is. So I'm going to go to Confluent IO, maybe, /hub. So it's an excellent question. Where do you store that? And so let's say I want to store this into, I'm just going to choose MongoDB. And I have different kinds of connectors that I could use for that. But I could store things on Snowflake, I could store things on S3 buckets, or whatever it is that you would like. Because let's say we're using our stream on here, and then we come up with a result. The result, all Kafka Streams is going to do is take that result and store it into a topic. That's it. But what if I want the results of that topic and store it into a database? That's where I can use something like Kafka Connect and store that into a database. Okay? So your question was multi-layered. Yeah, question?
Do you also have features like interpolation? We take, let's say, some samples are missing. Like Redis has the feature of interpolation along with aggregation. So do you have such features?
So what's the interpolation? Maybe I'm not familiar with that.
Let's say there's a counter, right? 10, 20, 30, and I miss data, right? 40, 50, and then I get 60. I do a trend chart, and some samples. So you can actually have an automatic injection of the samples you can
Yeah, that's definitely something that you can have. I'll have to take a look more at the Redis on what that is, because maybe we have it by a different name, perhaps. But it seems you can absolutely do that. That sounds a lot like imputation as well. Like for missing values, you're just filling that in as a gap. Yeah. Oh, it's already 10. All right. Oh my goodness. But yeah, I think that's possible. But I don't know if we have that out of the box. We may have, but again, things keep on growing. So on here, I could just aggregate. Whenever there's activity, I can aggregate that. And I could have one window that looks like that. Okay? So let me show streams on here and what a stream is. And here it is. So here's a stream, and here's the API that's associated with it. Application ID is going to be like the consumer or the group ID. And what I'm going to do here is I'm going to ingest it from a topic called My Orders, right? That's the thing that's been running right now. And what I'm going to do is I'm going to take that and I'm going to filter it. And what I want to do is I want to take that information, and if the key is equal to California, I want to put this into a topic called California State Orders. Pretty easy, right? And what I'm doing here is I'm creating a topology. Let me come in over here, and notice what I have here. I have this reference, which means I want to tap into the topic using a stream. And here's a filter. So I want to take that stream, and that's the variable name here, do a filter, and put that into another topic. Here's this stream here. What I want to do is a group by, and notice what this looks like. Here's the type behind it, K group stream. And once I do a count, table, right? It's not a stream anymore, it's a table. And what I'm going to do is I'm going to put this over into state orders count. Okay? And just do something with it and post it somewhere else. Here's the streams here that I'm going to be running. And I'm going to go ahead and start this one. And let's go ahead and take a look. So this has been producing. I also have consumers in here. So let me go ahead and run my streams here. And away we go. So should be running. And if I come in over here, what I am going to do maybe is come in over here and take a look right over here. California state orders. And if I take a look at the messages on here, we'll just let this move a little bit here. We should see, well, hopefully soon, that there should be some messages that come in for everything that is coming in California. And there it is. Here, let me go ahead and highlight. Oh, the values don't come in because they are numbers. So stand by. I'm going to do something here. And I'm going to open up the README, or it's called cheat sheet. Yeah, where are you? Cheat sheet, get over here. So what I'm going to do is this a California one? Yeah, here's the California state order. So that way you can kind of see what it is that I'm looking at. And what I'm going to do is I'm going to come over here to the services, and I'm going to open up broker in here. There it is. And what I'm going to do is I'm going to attach a shell. Is that right? Or create a terminal in here. Yeah, there it is. And I'm going to go ahead and bring this one in so that way we can hopefully see what's happening in here. And I'm going to run Kafka console consumer on California state orders. So that way we can kind of see what that looks like. And hopefully, there we go. Okay, so that's what's coming in. And that's the filtering on here. And if we take a look at this one right over here, notice these topics are created. And if I take a look at these messages now, what we should see here is the value, which we can't see in this thing here, but I have Nevada, but it has the aggregation per state, right? And so if I'm aggregating the total for a particular state, right, that's an aggregate, and I don't care about the past, right? And that's the idea behind this, okay? I'm probably going to go over time anyway. Okay, so just a little bit, hopefully not too much here. Does everyone get it? Everyone okay as to what a stream is? All right, great. Yeah, question?
So these APIs are provided by Apache only for doing the filtering?
Yeah, it's part of the Apache core. There are different licensing tiers. So all this is a part of Apache Kafka. Confluent has two different layers past that. And so they have things like schema registry and a few other services. And those are going to be open source-ish. But still, you know, for all of you, you know, that's, unless you're named after a river in Brazil, you're fine. But then they also have, you know, service things and stuff like that. But this is core and fully open source. No, it's already available. It's been available for years as well. Yeah, great question. So it's great if you're like, if you know your flat map filter for each, etc. What if you're not? Or what if things would just be simpler if you use this thing called SQL? That's where KSQLDB comes in. Data filtering, transformations, aggregations, joins, windowing, and that session. The way this works is that we can have a KSQL DB, and I'll explain what the DB is I'll hear a little bit later. But that's going to be a terminal that you can use to run queries without having to program in a functional way. That's the idea here. You deploy on remote machines, you have a CLI. You could also run in headless, which is a production sort of way that you go about it. Now, in order to run this, you need structure. You need structured data in your value, not just simple numbers like I was just showing you right now, but things that use Avro, protobuf, JSON schema, because my data is going to look like first name, middle name, last name, shipping, how much did it cost, what shipping method did they want to use, etc. Your choice as to how you want to write this. Do you want to write this using a producer consumer, or do you want to use the Kafka Streams, which is filter, flat map, and all that other stuff, or do you want to use KSQL? What I'll do is I'll tap into a server called KSQL and locate the address. Here's how I run this in production. So once I have a SQL that I want to run, here's the file that I'm using. And what this is going to do is it's just going to run that particular agent. Now, the way this works is you tap into a topic, is the way that works. And here's the tapping. So if I have page views, I want to state here, I want to tap into that topic because I perceive that topic as a stream. That's what that is. And the data is delimited, meaning it's a comma delimited file, and I'm getting it from this particular topic. The rest is a declaration. Here's table for users. I want to tap into that one, and we know what a table is now, right? Users is perfect for a table, and you get this instinct already as to what these topics are. Is it a table or is it a stream? And that's what this part is right over here. Given this structure, I have this topic, I have this format, and this one is going to determine what that key is. Okay? I could show the streams, I could show the tables, and I have SQL. I have all the supported SQL types, I have the operators, the aggregator, by the way, you need a group by first in order to use it. I could show the topics, I could show streams, tables, functions, and queries. And let me get to the big part here. So this is a non-persistent query, which is I want to look at all the page views where the time is greater than this and is less than this. Give it to me, and this is going to be a pull query. Give me the set. There's no more that I need to ask about. This is a fixed number, so that's a pull query. I'm just going to get one set from that. Push query, on the other hand, is give me the updates. Things are happening. Whenever there's new information, send that over. That's a push. And the way I do a push is with emit changes. And here's a persistent query. Notice the difference here. And typically what you want to do is you want to set up I'm probably going to go 5 minutes or maybe, 5 minutes over because I know, some of you need to head out. But notice this right over here. Select with an emit changes, meaning I want all the new information to be coming in as it is happening. And that is a push query. But notice this right over here. I have a select statement. And what I'll do is, whenever I have just a select statement, they're going to show up on the CLI, right? So I could see the results of it. But once I'm done with the results, what I want to do is I want to turn that into a persistent query. And here it is, right? Here's a select statement. But what I want to do is I want to add the following, which is, on this one here, this comes from users, which is a table, and all this one's going to do is filter a table and just, get all the users that are female and emit changes. So when new additions get added on, they will be sent over to a topic. And that's what a persistent query is. Whenever new changes are happening, send that one over to a topic. Everything is a consumer producer. The KSQL, the streaming, underneath it covers everything as a consumer producer. But how easy do you want it? KSQL is the easiest. A little bit harder is going to be the Kafka Streams, where you do the functional programming, but a lot more flexible than the SQL, particularly if you have a hard use case. Or you could just write your own consumer producer. They're all different manifestations of the same thing. Yeah, cool. So here's a big one here, and I'll do a demo right now. But this one is create a stream with 5 partitions. Oh, and check this out. If I want to say make it a JSON, I could do so. Select whatever it is I need from some other stream and then go ahead and emit those changes. All right, well, let me do a demo because I am running just a little bit over time, but what I'm going to do is I'm going to come in here and I'm going to quit a lot of these ones here, and I will close that one. And what I want to do as an example of this, here's that one, and I'll close that one out. I have this Avro producer here. And the Avro, the idea for the Avro is that it has a lot more structure to it. And what I'm going to do is I'm going to come in here into topics once again. And what I'm going to do, I'll make it 3 partitions here. And this time, you know, I have a bigger structure to this. That doesn't look right. But order is going to have an amount, has shipping to it, has a state, has a discount, and has a gender, right? A much more meaningful structured data inside of that value. So I'm going to go ahead and run that, and I'll show you a little example on that. And what I'm going to do is run that. Let's go and do my Avro producer, and away we go. So it's sending the information as it is right now. And what I'm going to do is come in over here to my cheat sheet, and this is what I'm going to plug in. And luckily, this web service that I have here has a KSQLDB as already a part of it. So I'm going to go to the cluster here, and what I'm going to do is I'm going to do this. And this is me tapping into that topic. And I'm going to tap into that topic that says my Avro orders. That's going to be Avro. And here I am describing the data. And I'm going to choose earliest, and I'm going to go ahead and run the query. And this is going to say, hey, we're successful. Okay, so what could I do with this now? Let's say select star from my Avro orders. I think is what it is. Emit changes, and then run the query. That's kind of a small font, so let me go ahead and run that. Or is it dash? Select star from, is it dash? Oh, no. Oh, this is odd. Let me run the query. Okay. Still wrong-ish. I misspelled orders. Let's go and run that. There we go. Look at that. Right? That's coming in. But if I want to say, show me the discount only and the shipping instead, here, let me stop and I'll run that query, and I get a different set of data as messages are appearing. That's KSQLDB. And then what I could do with this is that I can do, and I'll kind of just mimic this right over here. I could do create stream, whatever I want to call it, my shipping orders as select, etc. And what that would do, and here, let me do a stop here. I would run that, and it created it. And what we'll see over here is a topic based on what I just created, which is somewhere on here. What is it?
My shipping orders.
Oh, yeah, there it is. Yep. Right. And so it created a topic. And so that topic now has a different view of that data. Let me just go ahead and finish with this here, and then we could just hang out afterwards in the hallway, or if you have other questions, you can come towards the front here. Anyway, the other parts of these slides are available, and I'll tell you where these slides are, but I want to make sure that I cover these parts right over here. You could set up a connector which says, go to this MySQLDB, get everything on here because I want to query that right away. And that's what a connector is going to be. But I want to come in over to this. There are so many solutions, architectural things that you could solve with KSQLDB. How many of you know what a saga pattern is, or you've implemented one before? Okay? Saga pattern is an event. It's a domain event that is happening, right? Purchase has been made. I want to react to it and do something with it. How did you implement it? Do you remember? Or maybe it was a long time ago?
It was a long time.
It was a long time. A lot of people will just create like a Java application for that. But here's the thing. This kind of Kafka stuff is going to make you look good. Because if you look at this, here's what they are. All of these hexagons that you see here are microservices. So number one, someone just placed an order. Within this microservice here, you have a Kafka, well, my opinion, of course. You have a Kafka Stream application that's going to react to that new order that's coming in. And then what that warehouse will do is it will emit a message over to Kafka that says, all right, I've already reserved that stock. Okay? That's number two. Then number three, that microservice has a Kafka Streams that will react to this one and make the payment. Then this will say the payment is taken. The warehouse will react to it and create an order shipment from it. That's what a saga is. Every microservice is going to be communicating and could react based on that. There's some other patterns like CQRS. Anyone do CQRS? Command Query Responsibility Segregation. Someone was mentioning, hey, our database is really clogged up. Well, this one is you have one database that's responsible for the writes and the updates. But you have other databases which are your read models, a different view of your data. And these could be different databases. I have a architectural workshop. I can give you that GitHub if you're interested. But the idea for that one is one database is reserved for the writes, and a different database, it could be, if I have Postgres, I could have Mongo as a read model, and that just has a different view of that same data, but it's an aggregate or whatever it is you want. Outbox pattern. Two-phase commits are hard. What is a two-phase commit? You want to send to a message queue or like a Kafka as a pub sub, and you want to update a database. That's hard to do, and a better way to go about it is just update one thing. And that one thing is a database. You could use Kafka Connect for that. And event sourcing is everything Kafka. So it does a really good job for a lot of these architectural patterns as well. So wonderful workhorse for you to use, okay? So I'll go ahead and finish it here. And we could take questions that way. These folks can call it a day and go home to their loved ones. But if you have any questions, I'll stick around. Thanks, everyone.